As you can see, I have some very helpful tips which help me get through the day. Alright, so this thing we're having now, I'm recording a screencast. So whatever you see on my screen will be available at some later point in the future. So you set up Telnet, and I saw some of you doing this. So if you run Telnet, you get one of those prompts, just like you see on the screen. And then what next? If you see this, it means that Telnet is present. So this is good news. Now you can press something like Control-Z or Control-C or whatever to quit and try something else. Telnet 127.0.0.1. If you try that, it says, well, in my case, it doesn't accept the connection, and it most likely will be the case on your computers as well. In this situation, when I just give it an IP address, it means that it connects to the default Telnet port on that IP address, and the default Telnet port is, I think it's 23. So it tries to connect to port 23 on this IP address. The connection is refused because there is no Telnet server to which you can connect. Therefore, you get one of those error messages. If you want it to work, you have to specify some port number where you know that someone is expecting your connections. In my case, I do have an SSH server, and SSH happens to be using port number 22 by default. So if I write telnet 127.0.0.1.22, I don't get a connection refused error message. It indicates that a connection was successfully established. So now I have multiple windows. So you can see things happen in multiple places.
What package is that?
Which one? The one that gives you the helpful tips? It's a thing I wrote myself. But there's a YouTube screencast that walks you through the entire set of steps.
Did you do the
ASCII art?
Yeah.
No, those I just found on the internet. Okay, so in the upper window you have my Telnet session, and in the lower window we have another console where I can type stuff. I will type netstat -a -l, which means show me just the listening connections, and -n means show me port numbers in numerical form. And it gave me some output. It tells you many things. Alright, so this is where it gets interesting. Now have a look at this line. 127.0.0.1, port 22. 127.0.0.1, port 44,000, blah, blah, blah. And let's come back to this drawing here. If you scroll to the top of this table, you will see that this is a column for source, and this is the column for target, or the other way around, but it doesn't matter. So have a look at this interesting detail. You see this line and this line? Now think about it and tell me what your conclusion is. Well, since the client and the server are both on the same machine, then we have the same source and the same destination IP address. And in one case, we have the source port number set to 44,000 whatever, and the destination is port number 22. And on the other side of the connection, things are the other way around. So it makes sense. It would be really unusual if we didn't see that in Netstat. And as you can see, this number 44581 is a randomly allocated port by the operating system's network stack. It took a while to see which one was available and gave it to us. In the meantime, you can see in the upper window that the connection was closed by the server, simply because my SSH server is configured to cut you off if you're not doing anything for a while. And in this case, we haven't established a proper SSH session. We just opened a TCP connection, and that's it. If I run the same command again, and then I run netstat again, I'm going to give it another argument, which is -t. It means show me just TCP connections. So I don't get those long lists of Unix sockets, which were visible in the previous example. So now you can see that the port number allocated to me by the operating system is not 44,000 something, but it's a different number. So this is normal. It means that things work as they ought to work. Now there are a few more interesting things you can observe. One of them is this top line, which says interface 0000 port 22 is in a listening state. It means that so first of all, 000 is some sort of meta interface, which means all network interfaces. That includes the local host 127.0.0.1, and if I were connected to some network, it would also listen at that interface. So you would be able to telnet into my machine through that network interface, and if you're here, you could also telnet into it using the 127.0.0.1 interface. Were you able to replicate the same behavior on your systems? Yeah. Well, in that case, try something else. Have a look at this list and find sockets which are in a listening state and see the port number. So in this case, there's somebody listening at port number 445. So just because I can, I'm going to try and establish a connection to that port number. Yeah. Somehow I got connected and I can type stuff and send messages to whoever is accepting them, but I have no idea who that is. So I'm going to try this with -p. And let's see. Well, my tables. Well, if you press Control Z, you actually just, you kill telnet. That's a very dramatic way of disconnecting. But pay attention to the line above. It says escape character is, and then there's this sign and parenthesis. So it means control and that character. So if you press that, you go to the telnet prompt, where you could write a bunch of commands, and one of them is close, and then it closes the connection. So in this case, escape means that it takes you outside of the connections context, and it brings you into the context of your telnet client, where you could open a connection to another server, or just close this one, etc. So let's go back to our original question. Who is listening at port 445? And the answer is that it's Dropbox. And I can answer that question by looking at this part of the table. You could try to connect to another listening socket and see what happens. When I connect to this one, nothing happened, in the sense that the connection was established, but then the server didn't send me any message. However, I could type stuff on my keyboard, and that message would be sent to the server. It is then the server's responsibility to know how to parse that message and how to handle it. Since I wrote ALKWDA, blah, 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 which doesn't really make sense, the server didn't respond with some meaningful answer. It probably tried its best to interpret those characters, and there were no rules that would actually allow it to understand what that was, so it disconnected me. So that's your super fast introduction in the magical world of Telnet and Netstat. Now what I'm going to do is I'm going to fire up a Python console.
Can I ask a question?
Yeah.
What's about the asterisk in Netstat?
What does the asterisk mean?
Yeah.
Usually it means any, but in this case, let's just have a look.
Because there was something like client asterisk dot asterisk server asterisk dot asterisk, and it says that it's closed. So what's the one?
Wait a second. Let's try to replicate that. So which line are you talking about? Do you refer to something like this? Okay, so
Yeah, that.
the title of this column is foreign address. The socket is in a listening state, which means that it's not actually in a connection. It's waiting for connections. So that is just a way to indicate that there is no matching peer, but it will accept anyone who wants to connect. So the first thing you do in Python, if you want to program a server from scratch, is to import the module called socket. That's where all the functions that we previously covered are implemented. Yeah? You have a question? Alright, so there are multiple flavors of Python. There's the 2.x branch and there's the 3.whatever branch. They have a slightly different syntax, and version 2.x is not going to be extended with new features. At the moment, there is this political decision to switch it to maintenance mode and dedicate all the efforts to the extensions of branch 3. However, there are bazillions of deployments of servers running code written in Python 2.x, and there are gazillions of third-party libraries that work with 2.x. So depending on your philosophical and ethical views, you might choose one over the other. In my case, I'm using 2.7 simply because I have it on this machine. If you use 3 point something, the syntax will be somewhat different, but the differences are not super major. So if you want to take the easy way out and just follow my samples, then setting up 2.x by by the side of 3.x, they can happily coexist on the system. That would be the safest thing. Otherwise, you would have to spend a little bit more time and dedicate some extra efforts to figure out what the differences are and how to call those functions using a syntax which Python 3 will accept. Do you have other questions? All right. So we have imported the sockets module. To verify that it was imported correctly, you could just type socket, and it says something like this: socket from blah blah blah, and it tells you which file the module was loaded from. Alternatively, if I'm trying to import a module that doesn't exist, like this one, it will say there is no such module. So there you go. I am now going to start implementing the actual server, or a primitive server. I will create a listening socket. The notation socket.something means the socket module followed by what you want from that module. So that's why I wrote socket.socket, meaning I want the socket function from the socket module. I can then bind it to an interface, which is a tuple of the form. One of them is the address. I will use the local host address, passed as a string, so it's a quoted string. And the second element in the tuple is the port number. And I'm going to use port number 50,000. Did everybody else get this far? Or is it just me? Is anyone having trouble? Okay. Yeah, the problem is that you're doing this in Telnet. I'm doing this in Python. So you should just open another console window. Now we'll start Python. Anyone else having a hard time?
Do we have to use different ports numbers?
Well, you could use the same port number as I use.
You shouldn't by now in Netstat.
Yeah. So one of your colleagues asked whether at this time we can already see something happening through Netstat. No, not yet. Not before we call the listen function. So just to give you a taste of how it's supposed to work, I'm going to run Netstat and say show me all connections in the listening state in numerical form with a process ID. In Linux you can combine command line arguments like this, or you could do it like I did it in the previous samples. Okay, I'm going to add the T argument so it shows me just the TCP sockets. So if you have a look at this list, you don't see anything related to port 50,000 yet. But we're almost there. As soon as I call the listen function, Netstat should tell us a few things. Now this one takes an argument at the input, which tells us the maximum number of connection requests that will be queued. Whoever attempts to connect when the queue is already full will get a connection failed, or connection rejected, or connection timed out. Well, they will not connect successfully. So I'm just going to use the number 5 here. So if you press enter and go to Telnet now, you should see that there is a new port number in that list. To reduce the amount of output, I'm going to use this tool called grep, which will show me only that line of the output which contains the string 50,000. So what do we see? In this case, we see that somebody has opened a connection, has opened the listening socket at port 50,000 on the localhost interface. The connection, the socket is currently in the listening state, and the process responsible for it is Python, and its process ID is 6904. Did everybody get this far? Okay, that's good news. Is there anyone who hasn't gotten this far? It's
Yes.
all right. Do you need assistance?
No, just didn't hear. There was which part are you seeing? Could you go back to show me the command you used? It actually doesn't work. What? It doesn't work. It doesn't actually get the output. But you grab that one. Because you're a super fancy terminal anyway. So the thing is that for some reason your Netstat doesn't show that connection. Could be a couple of things. I think we could research that. For now, let's go back to the demo and it doesn't. There is this special term which describes this kind of situation.
Windows достаточно наносит. Например, Windows не есть где. Windows was committed such a magic coordinates. So тренеры Windows платформу.
So did everybody get this far? And all right, so I'm going to repeat my question. Did everybody get this far? So the cool thing about Python is that we can do things in real time and observe the consequences of our actions in real time. And in this case, we can observe that as soon as we called the function called listen, we got some feedback, and we could see that in Netstat as a new listening socket. So now the server is listening for incoming connections, but let's try to connect. So I will write telnet 127.0.0.1 port 50000. It says that the connection is established, which is somewhat strange, because we haven't yet called the function called accept, which probably implies that the operating system, or at least on this platform, the implementation is such that it uses some buffering or some caching magic and takes care of things in the background, even though we didn't yet call the function called accept. So let's see what happens now. If you remember, the accept function gives you back a new socket object that corresponds to the connection with the given client. So result equals listening socket dot accept. Something happened. Now let's see what result is. And we see several things. That result is actually a tuple that has two elements. The first one is an actual socket, the thing I mentioned earlier, and the second one, so this is the first one, it's the socket object, and the second one is another tuple which tells us who the peer is. This is the IP address from which we got the connection, and this is the port number on the client side. And this thing is also a tuple which has two elements. So we got a result which is a tuple that contains a socket and another tuple. If I want to talk to the client using the socket, I have to get it out of the tuple somehow. So I could do this. The elements have a zero-based indexed. So if I say client socket equals result of 0, I am just extracting the first element of that tuple. Or I could also do some Python magic. It's called tuple unpacking, and it works like this. So let's say A, comma B equals result. So what this means is that I am taking this variable called result, which I know is a tuple, and I am unpacking it such that the first element is mapped to variable A, and the second one will be mapped to variable B. So now if I write B, I get that, and if I write A, I get this. So it's a little interesting piece of syntactic sugar, in my opinion. So now we have the client socket, which is an object that we can use to interact with the client. Now I am going to use the send function to send a string to the client. Tell me what I should tell to the client. Some very profound message. Did you notice something in the window above? Yeah, so there are several things we need to observe. One of them is that our message was typed on the Telnet console. The second one is this number here, 18. What does it mean? Is it
It's the legal age to get married, drunk, and have kids.
yeah, it's the legal age to get married, drunk, and have kids. But in this case, it happens to be the length of the string that we sent. So the send function returns us an integer that indicates how many bytes were successfully sent to through the connection. I could also send more stuff. For example, I can send the string hello multiplied 10 times. I could send the string hello multiplied 10 times. Excuse me? Yeah, okay. Let's send them a new line. So in other words, I can use the send and the receive function to interact with my peer. Now let's try it from the other end of the connection. I am now in the Telnet session. Tell me some other profound message that I could send to the server. I don't know that language. Something else? All right, Hungary, just as you said. And obviously, nothing yet happens on the server. Why? Yeah, nothing happens until you specifically tell the server to get something done. And in this case, I am going to call a function called receive. And let's attribute its response, whatever it returns, to a variable called data. And I'm going to tell it to receive 10 bytes. Something happened. So now I'm going to view the contents of my data variable, and the contents is Hungary \r\n followed by an m, which is this part. You can see the \r and \n. These are characters that are interpreted as a new line and a carriage return. Depending on your operating system, you might get just a \n or just a \r in certain cases. So did you observe the same thing in your own client and server? I mean, in your own servers? Did anyone get some completely weird output which doesn't resemble? Yeah, the B is not inside the quotes, it's before the quote, which means in Python 3 syntax that this is a binary, it's a sequence of bytes.
What does a broken byte
In which context?
Second error.
It means that the connection got broken. And in your specific case, this could have happened because at the time we were experimenting, yeah, that's what you get when you kill them.
No. I just wanted to know what the
Yeah, it means that
I
branch,
realized it.
branch upon which I was standing was cut off unexpectedly.
Да, была линия написать. Чек.
So we've had a 15-minute break. What happened to our connection, in your opinion? It got paused, it got cut. What else? Nothing. Well, there is one way to verify that. And we can do that using Netstat. I'm going to run it again. I'm going to look for my specific port number. Oh. Yeah. So I'm going to run the following command. And I see that something is still going on. On port 50,000, my server is still listening. And well, it's supposed to be alive. So this is explained by the fact that we are using a transport layer protocol known as TCP. This is what happens here when you don't give it any arguments. By default, it assumes that you want a TCP connection, which implies that it's a reliable connection, meaning that it will stay alive until someone says disconnect, or until something terribly bad happens and the universe disconnects it for you. So if I call the receive function again, I will, in theory, get more data. You see? So I still keep receiving stuff. Now there's one other thing that I have to point out. I'm only reading 10 bytes at a time, but there is more stuff left to receive. And those bytes are not going to evaporate. They will stay there in some buffer managed by the operating system for us. And every time I call the receive function, it reads from that buffer. It doesn't go to the client directly and say, hey, give me the data. It just accesses its local buffer, and the operating system takes care of pushing more stuff to that buffer whenever the client sends anything. So let's try another one. And I go back. Let's see if I could also give it a very big number, such as this one. Read 100,000 bytes. And in this case, it will read up to 100,000 bytes. If there is that much stuff, it will give me 10,000 bytes. If there is less stuff in the buffer, it gives me everything that there was in the buffer. And another interesting thing, in Python, if you type the underscore character, it is mapped to the value returned by the previous function call. So I could do something like, let's say, response equals underscore. You can't really see it because it's tiny, but it's there. So now I can type response and I get the same thing. I can also see the length of my response, and it's 44 bytes. 44 is less than 100,000, but that's as much data as the buffer gave me. So now I can send more. And I can, yeah, you have some remarks?
Yeah. I just tested it another way. First I let the client receive some bytes.
Mm-hmm.
And I actually found out that receive is also a blocking function. And maybe you should do it backwards to show.
Okay. Yeah, so the receive function, let's try to call it again when there is nothing in the buffer. Oh wait, now there is nothing in the buffer and it's stuck, which is another example of a blocking function call. And if I type one thing now, there you go. It is interesting in this case that telnet actually sends stuff when I press enter. Why would I say that? Or how can we observe that from this behavior? Yeah, so if I type many letters, if telnet actually sent them, then the receive function would return right away, giving me 1 byte at a time. But it wasn't the case.
You can check now before the second.
Yeah. Before I press enter, nothing happens. Well, at least this is the specific behavior of telnet on this platform. But it doesn't mean that I can't write another client which will send things as soon as I type something. Why doesn't it take 1 character? Well, that's just a design decision inside telnet. If you want, we can set up another client in Python. So let's do that.
First fill.
No, I just go here. I created another terminal window. So I'm starting another Python console. I'm going to write another client. So your colleague would suggest, I mean, my colleague suggested that this other Python thing that I'm going to write won't bind to the server, which is true because you can only have one server listening at one port at a time.
How do you explain that the port on Netstat has also listening and establishment at the same time?
Because there are actually two sockets. One of them I named listening socket, which is the socket that accepts connections. The other one is the client socket, which is the socket given to me by the accept function. So there are two of them. So I do the same thing, import socket. We could try what Dima suggested and try to have two listening sockets at the same port at the same time. Hypothetically, there will be an exception. So let's try that. s.bind. I'm going to bind it to the same interface. That's 50,000. Well, and it says address already in use, which makes sense. But in any case, my intention was to write another client, which would send things right away. So let's go ahead and do that. So I'm going to connect to the same address and the same port number. What did I just do? Could you provide some comments? Yeah, so now I have three sockets. The listening socket, which keeps accepting connection. The first one called client socket, which is mapped to my telnet connection. And the other one is the new socket, which I called new client, which contains which corresponds to the connection with this other client you have in the window above. And actually, new client is not a socket, but it's a socket and a matching peer address. So I'm just going to get the actual socket out. So let's try to send something to the client from the server. The function returned 4 bytes. It means that it has successfully sent 4 bytes. Notice that I haven't yet received them in my client, but the server thinks that it sent them successfully. And it's not magic, it's because there are buffers on the client's side which take care of that. And as soon as I call the receive function, it will be reading from that buffer. So let's try that. Receive 1 byte. So now it received test, the 4 bytes that were there, and if I called it again, telling it to read another byte, it's stuck. It's blocking because it's waiting for the server to send something. So let me send it a byte. In this lower window, you see that send successfully returned 1, meaning that 1 byte was sent. In the upper window, you see that the socket received 1 byte, which is \n. I could also do something like that. For I in range 10, So now I'm going to receive 1 byte in a for loop. You see, now it's received as soon as I send it. And now if I send more bytes, what is going to happen in the window above?
Just a part of
I didn't hear that.
just a part of them.
So let's see. Yeah, so it received more bytes at a time. So now I can keep sending and sending and sending. All of this stuff is buffered on the client's end. Now I can do, oh, I can use a while loop. Well, let's see what just happened here.
Actually, nothing, but you're not printing the result, you're using it to check.
Yeah, but that's not the correct explanation. So the receive function is supposed to return me some data. And I gave it a while loop which was supposedly executing those things inside, and for as long as the function returns, it keeps doing something. But because the receive function is a blocking function, now it's stuck inside that loop, and I'm not going to get out of it in a million years. Yeah, but all the information is supposedly going to be received. But I can try this. I can close the connection, and the receive function, which was blocking, tripped upon an exception. The connection was broken. So now I'm out of that loop. And if I'm trying to do something with this socket now, let's say receive more stuff, nothing happens. So, and it doesn't block. Yeah?
Why didn't we receive all the from us when we went for a while?
On one hand, it makes sense. So your colleague explained that we didn't output them because there was no print statement. But if you paid attention, wait. Up here, we never used a print statement. Nevertheless, it did print out something. So what's the answer to this one? Yeah, the while loop consumed the returning value, which in this case we were looking for. In this while loop, we were looking for anything other than false or none, which is the thing in Python. So for as long as the receive function gave us something, while happily consumed that answer and kept on calling the receive function again. And at some point, when we stopped sending stuff, it blocked inside receive. And one way to unblock it was to call the close function on the server's end. So at that point, the receive function didn't return anything, which in this case is an empty string. You can see it up there. You have just 2 quotes and nothing between them. That's an empty string. What are your other questions? Well, if there are no questions, then I think this concludes our introduction to getting things done with clients and servers in Python. So we can move on to the actual assignment.